Okay, so what we're going to do here is this is the second time we've gone through the material, so we're going to hit it a little bit faster. Some of the videos we may stop for, some of the videos we may skip over because if they're too long, because what this is a quick review. So this is kind of like the no nonsense review of each chapter. So we're going to go through these, and like I said, this isn't ideal. This isn't the first one you would want to watch. You want to watch the set of videos that are the introduction to the chapter that goes into more depth. But this right here is just a quick hit second run through, gives you a chance to review, and sometimes going through the material even faster that second time helps you remember what the first time you heard it, the first time you read the chapters, the first time you really studied the material, and it gives you a chance to do a review. So we're going to jump in to chapter 1. And so chapter 1 is talking about the cloud principles and design. So chapter 1 starts out, and I'm going to read the first paragraph here. I think it's a good one, and it sets the stage for the rest of the book. It says, "Welcome to chapter 1 of the Cloud Essentials course. The computer industry is an industry of big new trends. Every few years, new technology comes along and becomes popular until the next wave of newer, faster, and shinier objects come along to distract everyone from the previous wave. Thinking back over the past few decades, there's been several big waves, including the rise of the internet, wireless networking, and mobile computing. So, things that I've seen in my time. So, I started getting into computers mid 1990s. I was going to college, and then I started my career in the late 90s, around 1998. And the things that I've seen just in my lifetime, we had mainframes with dumb terminals. And then we moved away and we had something that we called like fat clients, where the client started getting a little bit smarter. So we could do more processing on the computer that was there on the desk in front of us. And then we also started introducing something called mid range servers. This is a lot of Unix machines and Windows servers, really back then, mainly Unix machines. And so we were putting them out there, and we had these wide area networks so that these machines could talk to each other. And then the internet. The internet was always there from the 90s, but it wasn't really as big as it is now, and it was slow. And so even when I first started working at a large company in Kansas City, we would have one computer per floor that had access to the internet because it didn't have a business purpose when it was first getting started. I mean, there's a lot of commercial reasons, but really, if you needed something, you would have to go over to where the one person in the on the floor that had the internet and say, "Hey, I need to go look up some information." And at the time, it was a lot of information on oracles, what I'd be looking up. So he'd have to get up from his desk. You would sit down, get on the internet for a little bit, figure out what you want, and then hand it back over to him. So the internet wasn't a major disruptor in the field for a while, and then when it finally took over, it just blew up. You know, everybody started getting on the internet, and then we had e-commerce and all the things that came from that. And then after we started moving like that, and we're still into our mid-range systems, we have our intranets, and we start doing things on wide area network, and then we started using the internet a little bit more. The industry really started going towards decoupling of services. So we were using service buses where we would put our services out, and we would have the service do all the work. Like the service would go look something up and bring it back. And so we would have the application that was calling that, and it would come in, make the call to the service bus. The service bus would do the work, reach out to the system that had the information, pull it back in, and then give it back. So this started helping us decouple our um, services. And then some of the service buses were Tibco, Oracle Service Bus, Fusion Middleware. And then now we've moved into the cloud. And the cloud was, we've always been able to do cloud type things, or I shouldn't say always, but for nearly 60 years, we had the ability to do cloud. Our problem was we didn't have the network, we didn't have the backbone in order to do cloud well. So when the internet got bigger and better and faster, and now that we have enough fiber out there, that's when people were able to say, hey, this cloud concept that we have, we can go bigger. We don't just have to do it inside of our own data centers. So thank goodness people like Amazon Web Services who were doing cloud in their own data centers. decided to open their doors and say, let's see if somebody wants to buy this technology. If somebody wants to come in here, sign into a web browser, create a virtual machine, and use it, and then they can buy all these other services. And then quickly after that, Microsoft came in, and then now we have multiple cloud vendors out there. The big four usually still remain AWS, Microsoft Azure, Google Cloud Services, and Oracle Cloud Infrastructure. All right. So that's all in the introduction. And so the first time when we have a class discussion, we'll talk more. We would talk more about this. But now that this is a time of review, but still think about the trends you've seen in your lifetime. And what are the big ones today? And I've kind of walked you. I just walked you through what the ones that I've seen in my lifetime and where I feel like we are today. All right. So in chapter 1, the discussion topics are understanding cloud principles, exploring cloud design, and then we'll have a summary. And you know how this works. We'll go through the exam essentials and then the written lab and the review questions. All right. So I know that now all of you in this review, you already know what the cloud is, but you'll remember when we first started talking about this. And so what does the cloud mean to you? And so some of you were talking about iCloud, thinking about Gmail, all the G Suite, where you can go in and have pretty much an office suite and be able to use all of these tools. And of course, Google has multiple tools that we can go in and use as consumers. Some of you mentioned Office 365. So when we think of the cloud, we're thinking about these services that we just sign in and use. But what I was telling you on night 1 is after you study it, you'll never think of the cloud again in the same way. What you know now is the cloud is really just getting work done on someone else's computer. And in the case that we're studying the things that we're doing, we're talking about Amazon Web Services, Microsoft Azure, Google Cloud Platform, Oracle Cloud Infrastructure. They have the data centers. So it's not like this work is getting done magically somewhere. It's very well orchestrated. These companies run their data centers. We've learned how the data centers are within about 30 miles of each other, and then they're inside of a region, and then the geographic regions, there's multiple throughout the country, throughout the world. And so, but at its core, they're still data centers. They're still machines. They're just running slices, and we'll go into this in chapter 1, but they're running on top of the hypervisor, creating this environment that we call the cloud. All right, so if we were reading, we'd go through the understanding cloud principles. What is cloud computing? Accessing remote servers that provide software, storage, database, networking, and other services. So we're going to learn about the other services later. So going forward, your description of the cloud is going to be a little bit different. You know what the actual definition of the cloud is: getting work done on somebody else's computer. All right. And then we're also, we've been through and we've talked about the big four, talked about Amazon Web Services, Microsoft Azure, Google Cloud Platform, and there are many, many others. So there is the article. I'm not going to click on the article now, but you can go through that. And remember, that article is the one that tells us about where where the cloud service providers stand today and who has the biggest market share. So what are some advantages to cloud computing? So customers pay for the only resource, only the customers can pay for only the resources they need. There's no upfront capital for servers that will be outdated in years. It's often cheaper than the alternative. Access to resources from anywhere in the world from multiple types of client computers and devices. Flexibility and scalability because additional resources can be quickly added or removed. Access to the newer technologies without someone needing to take a long time to set them up. Data protection through the use of enterprise level backups, and reduced IT staff and administrative cost. So some of the disadvantages to the cloud, I think we've talked about this multiple times. You have to think, what are the disadvantages? But then when you look at these, you think, are they really disadvantages? But if you were going to list what are the disadvantages of the cloud, security. The client data is stored on someone else's server. Potential downtime if you're not in complete control of the data center. So you don't own it. But if you look at those things, there's also those disadvantages can also be some advantages. Security. Do you think your company's better at security, or do you think Amazon Web Services is better at security? Maybe you are specialized. Maybe your company does do security better than anybody else. But for most cases, to stay up to date and everything, you're probably better off with Amazon, Microsoft, Google, Oracle running your security platform. um, Potential downtime. That's the case everywhere. But who's more likely to have downtime in their data center? Your company or Amazon? I'm not saying it doesn't ever happen. It does, but the chances of an Amazon web center going down is probably or data center going down is probably less than your data center. But depending on who you are and what company is involved, you could make an argument for that. All right. So the first virtualization, how does it work? There's not a one-to-one relationship between physical server and logical server because we know that how virtualization works. We have a really big server. We run a hypervisor on top of it. This allows us to take that really big server and make smaller slices and to parse out and to give someone else access. We'll go into more detail about the hypervisor later in this chapter. But here, just with the basic understanding of how this works, we know that the physical server has nothing to do with the logical server. We parse those out and we hand out the logical server. So what are the benefits to this? We reduce upfront hardware, continue operating costs, we minimize or eliminate downtime, decrease IT productivity and responsiveness. I'm sorry, increase IT productivity and responsiveness, greater business continuity and disaster recovery response, simplified data center management, and faster provisioning of applications and resources. So let's take a quick look here. How do the CSPs define it? So the first one we're going to look at is VMware. People ran VMware in their environments for years and years, many more years than Amazon and Microsoft has been around. And people still do this. I was on a call today with people who still run VMware inside their own data center. So VMware says, what is virtualization? It's create a software-based or virtual representation of applications, servers, storage, networks to reduce IT expenses while boosting efficiency and agility. Let's see how Microsoft defines it. Microsoft says virtualization creates simulated or virtual computing environments as opposed to physical environment. Virtualization often includes computer generated versions of hardware, operating systems, storage devices, and more. This allows organizations to partition a single physical computer or server into several virtual machines. Each machine can then interact independently and run different operating systems or applications while sharing the resource of a single host machine. All right, see about Amazon. Amazon says virtualization is a technology that you can use to create virtual representations of servers, storage, networks, and other physical machines. Software mimics the function of physical hardware to run multiple virtual machines simultaneously on a single physical machine. Business use virtualization to use their hardware resources efficiently to get greater returns from their investment. It also powers cloud computing services that help organizations manage infrastructure efficiently. And then finally, let's check the IBM definition. Virtualization is a process that allows for more efficient use of physical computing hardware and its foundation of cloud computing. So now back to that first thing we discussed, the hypervisor. So it's very important to understand what a hypervisor is. The chances of you going to work somewhere where you need to do work on the hypervisor is very, very slim, but still, it's a good idea to have a basic understanding. It can help you talk with Amazon resources, Microsoft resources. If you have a ticket, if they're describing to you issues and they talk about the hypervisor, you need to have a basic understanding of what they are. So there's two different types of hypervisors here. Type 1 hypervisor. This is where you have the hardware running, and then you have the hypervisor, and then each operating system. And then on top of the operating system, you would install different applications. The type 2 hypervisor, you have the hardware, and then here's the difference. They have a host operating system, and then the hypervisor runs on top of that. And then you have your guest operating system here, and you run the different applications on top of that. Again, you don't necessarily need to know that, but you do need to understand that there are two different types of hypervisors and that the hypervisor is what makes cloud computing possible. All right, so now if you were reading along on page 3 and 8, now that we have a good understanding of virtualization and hypervisor, we're going to read chapter 1, pages 3 through 8, including the real world scenario on page 8. So, of course, you've already read the chapter, but when we went through it the first time, this was the breakdown. So, why understanding virtualization is so important? Again, the reasons that I was telling you about is it's important because you need to understand it in case you are talking to those people inside the data center. That would be the time that you would need to understand exactly what that hypervisor is, mainly so that you can take that information and describe it to your customers. Okay, so now we get into our different service models. And I've told you before throughout the class how important it is to be able to speak to these and to be able to bounce back and forth and so that no one has to take time out to explain it to you. Plus, when you're the one that's doing the presenting, it's very helpful if you can make sure that everybody has a basic understanding of what the service models are, and then it helps you describe it so that you don't have to go into great detail on each of these. And whenever you say we're talking about IaaS, everybody understands that you're talking about you're replacing the building, the network firewalls, the servers and storage, but essentially you're replacing your data center. But then you move into the PaaS model, and you're also including the operating system and the development tools. So you're saying, I don't want to own these either. I want to move these into the cloud service provider. And then the last one, SaaS, this is putting it all together. This means that even the applications are going to be managed by the cloud vendor. So when we think of SaaS, we think of things like Google Mail, Google Docs, Google Drive. When you have no idea where that is even being run, then you know that you're in a software as a service type of model. So we'll go back through these real quick. IaaS, of infrastructure as a service. It's virtual hardware that replaces physical on-prem infrastructure. And then platform as a service. Add to the IaaS, it includes operating systems, databases, services, and development tools. And then finally, software as a service. This adds to the PaaS model, and it includes all the applications. So again, when you're going through these, it's a good idea to print this slide out, get in front of a mirror, describe them. If your spouse can stand to listen to it, describe it to them, help somebody else understand the difference between these, and it will help you be able to speak to them. And it's not something you want to have to refer back to if you're in a business environment. You want to make sure that you definitely understand what these are. Okay, so then we took time out and we did this Google exercise. So I'm going to run through this quickly. Um, and this is things that you already know, but I'm still going to go ahead and do it just in case anybody wants to see this. So I'm going to go here and I'm going to open up Google. Actually, I'm going to go to a different screen. I'm going to go here. I'm going to open up a tab. I'm going to go to google.com. All right, so we all know what this screen looks like. We've been going here most of our lives, it seems like. But if we look right up here, we can see that I am signed in. So this is jeff.ratcliffe.teachit@gmail.com. So this is my user ID. And then if I go to this little box, here are the Google apps. So Google always, they'll add things into these apps without making a big deal, but you can search even for more Google apps, but we usually have a good idea of the ones that we like. So I can go here and I can look at my mail. I can look at details of my account. I can go to my Google Classroom. Let's go ahead and click on this. So here is our classroom for this class right here. Um, and then I can go here and look at some more. I can go to my Google Drive. So what the lab and exercise is really wanting you to do is get in here and play around and see what's going on. You can look at your Google contacts, your calendar. You can also use Google Translate if you haven't ever done that. That's a really neat program, one that's a good idea to have on your phone. You can store photos out here. Of course, we're all very familiar with our Google Sheets, Google Docs, Google Slides, kind of like a little office replacement that we can utilize out here. So the point of all this is software as a service. Some of you probably have access to every one of these and you haven't even paid for it. I do pay for mine because I use enough space that I have to have, I need to give them a little bit more money, but even then it's not much. But, I have access to maybe a little bit more than you do on the free version, but all of these are available for free. So that's everything around that lab. Okay, and then our book wants to point out that it's not just those three, our platform as a service, software as a service, infrastructure as a service, but actually you can put as a service in front of just about everything. And it's not just a matter of playing with the words and putting as a service in the middle of it. But if you can take that out of someone else's data center, put it into an application. So Amazon, Microsoft, Google, Oracle, IBM, all of these cloud teams and cloud organizations will create these things that are as a service. So what the good thing is now you don't have to do those things in your own data center on your own machine. You can go out and purchase for a use, usually very, very cheap, and be able to use that. So when you're reading through your book, some of the ones it's talking about here, business process as a service, communication as a service, desktop as a service, which is getting really, really big, and we'll talk about that more and more. Data as a service, database as a service, disaster recovery as a service, functions as a service, hardware as a service, information technology as a service, monitoring as a service, networking as a service. So anything and everything as a service. All right. So then here on our out of our book, figure 1.8, reviewing the cloud service models. So here's in a little bit prettier little picture showing you what these mean. So we start at the bottom, infrastructure as a service. That means we've taken our compute and our storage and our network. I call those our big three. If you have those things, you can do everything else in IT. You can replace a data center. You do not have to have your own data center because you have the ability to create servers, your ability to create storage, and the network to hook them all up. But of course, that's not where we stop. There's many other services that come in. But if you're doing infrastructure as a service, that's where you start. And then you do the platform where you include other things like our object level storage. We'll talk more about the storage types of identity and access management, runtime, queuing, databases. These are services that you add on top of your infrastructure. And what you're saying is, I don't have to be an expert in these. I can go use the products that are available to me. And then you come up here and you add application as a service. That's one of your highest level. I don't even care where it runs. I want to go out there and get my mail. I want to be able to monitor things. I want content delivery, collaboration, communication, finance. So that's where your software as a service is that highest level. Another thing you need to be able to speak to when you're talking about cloud is your different deployment models. These are very simple, but still things that you do need to know. This is another one of those opportunities that if you don't know it quite yet, what you should do is get in front of a mirror with a cue card, describe it, and make sure that you can speak to these. Again, these are a little bit easier than the as a service ones, but private cloud, what private cloud means is that you do have a cloud environment, but the cloud is running in your data center. You own it. So whenever we talk about private cloud, we're talking about a cloud that you own and you're running and you're doing. Now, when we talk about on-prem, that also includes all of the physical servers. That's everything inside the data center. So on-prem means you own it all. And then we have our public cloud. These are like your commercial CSPs, third-party companies like AWS, Azure, GCP. There's probably any number of these. And then you have a hybrid, and that, of course, is a combination of both. So most of the things we do are in the hybrid world. I mean, there are some companies that end up moving everything out into the cloud and they get to tout that they are completely in the cloud. But for the most part, most companies still have some kind of tie into a building, a data center, a location. And so, there's many more hybrid clouds out there than there are completely cloud environments. All right, the next thing we want to go into is our cloud characteristics. So, we've already talked about this. You know that cloud is actually getting work done on somebody else's computer. But NIST actually publishes the principles for cloud. And this says cloud computing is a model for enabling ubiquitous, convenient, on demand network access to a shared pool of configurable computing resources. For instance, networks, server, storage, applications, services, and they can be rapidly provisioned, released with minimal management effort or service provider interaction. So really what that's saying is that you can sign in to a console, deploy machines out there, and then sign into those machines and do work. So what are some of our cloud characteristics here? They're elastic. They can grow and shrink based on needs. Self-service or on-demand. Their scalability, they scale geographically. Broad network access available over the internet, pay as you go, and availability. And we'll talk in more detail about all of these later in the chapter. So we have our shared responsibility model. So an old network adage is a server is perfectly secure until you install a network card. So if you don't get that, what that means is that a server can be sitting there running. As long as it doesn't have a network card, that means no one can get on it except for you, a keyboard, and a monitor. But as soon as you put a network card on it and hook it up and allow users in to use it, you've opened it up. So in the shared responsibility model, the CSP and the client share security duties, which improves the overall security of the system. The CSP is responsible for the security of the cloud, while the client is responsible for security of what's in the cloud. So let's take a look here. This is the shared responsibility model. So remember, cloud provider is responsible for what's of the cloud. That includes the compute, storage, networking, databases, regions, availability zones, edge location. So what this is saying is Amazon, Microsoft, Google, Oracle, IBM, they own this. They own the physical building. They own the security of that building. They own the hypervisor. They own all of the networking. They own the different data centers. They own all of those parts. But the shared responsibility part is where us, the customer, comes in. They're responsible for what's in the cloud. So the things that are in the cloud, network traffic, file systems, data encryption and integrity, operating systems, network, firewall configurations, platform applications, identity and access management, and customer data. So the customer is responsible for what's in the cloud. Cloud provider is responsible for what is of the cloud. So I think one of the examples in the book, let's say that you buy a new house, the builder is responsible for everything that went into that house. If something breaks, they're supposed to fix it. But if you don't lock the front door and somebody comes in and steals something, the builder of the house is not responsible for that. So here's a little bit on cloud design. A well-designed cloud solution can save a company money, no sunk cost, no upfront cost, faster and better access to data. And so now we're going to focus on the third major area, recovery. All right, recovery and high availability. So redundancy and high availability. You want to be redundant with your hardware, network, geographic location, software, data. So all of these come together to create high availability. We're not going to watch the video now, but you have access to it. um, but high availability, what this means is that hardware will fail. So what do you put in place to make sure that when hardware fails, you do not suffer? Your customers do not know. So we'll talk about this in great more detail over the next couple of chapters. But here, what we're going to focus on is saying we know we need to be redundant. So if something happens to one of these items, it will fail over and go to another one, and the customer never even has to know that there was an issue. All right. So then the next thing, or might be the last thing that we're going to talk about here, is disaster recovery. So whenever you see DR, BC, or disaster recovery, business continuity, these things always go together. And 20 years ago, it was okay for you to tell your business that we lost this week's data. I mean, it's completely unrealistic to us now. But let's say that I was working and I had a bunch of engineers that were on my system and they were provisioning networks out there. And we had a major outage. I'm talking a once in a lifetime outage. We could go back to our business and say, guys, sorry, but all the work you did last week, you're going to have to redo because we had to go pull a backup, run it over the weekend, and reload the system. Everybody would say that stinks, but that's how it was. But then 10 years ago, you'd be run out. There is no way in the world you could say we lost last week's data. You That's not a thing. We need to think, how do we make our systems better than that? So 10 years ago, maybe a little bit more, it might be okay to tell a group, sorry everyone, we lost yesterday's data. You're going to have to go back in and provision everything that you provisioned yesterday. But today, that's not acceptable at all. It's barely acceptable to say, guys, we had a major worldwide catastrophe. We lost the last 5 minutes of data. People are like, how in the world could you lose the last 5 minutes of data? So we don't even do that anymore. Now, we pretty much, we might be able to say, okay, something you did 3 seconds ago, you have to redo, but we expect our systems to recover better than that. So some of the verbiage around this, and we'll talk about this now, and we'll talk about it later in some other chapters. We have our RPO, which is our recovery point objective, and our RTO, which is our recovery time objective. So in short, what these are, and this is just an introduction to these. Recovery point is saying at what point can I recover it? Is 5 minutes ago okay? Is a week ago okay? Or does it need to be, less than a minute ago? And then RTO is how long will it take me to recover the systems if they're down? So if I say we had a major catastrophe, the systems are down, and right now you can't even sign into the system, but I can get them up, and whatever time is acceptable for me to get those systems back up, that is your RTO. All right. So in summary here in chapter 1, we talked about our core cloud concepts, talked about virtualization and the hypervisor, and our service models, meaning our infrastructure as a service, platform as a service, software as a service, and other service models. So anything that's as a service. Then we talked about our deployment models with our public, private, and hybrid. And then we talked about cloud design. All right, so here are our exam essentials, and you'll get used to these. And I know that you guys have been through these once before, but the exam essentials are like your flashcards. These are the do you understand everything in the exam essentials? And if you do, then you're ready to be tested on the material. And if you go through and you take a test and you find out you're not ready, this is the kind of stuff that you would want to go over to know where you need to study again. And of course, reading the entire chapters will be very helpful. All right, so know what SaaS or SaaS is. It's software as a service, means that the CSP provides software for the client as well as the underlying hardware needed to run the software. Popular examples include Microsoft Office 365 and Google Docs. So remember, SaaS is the top level. It's I'm doing infrastructure as a service and platform as a service and software as a service. Next one is infrastructure as a service or IaaS. Infrastructure service is set up. The CSP provides hardware infrastructure. This means compute, storage, network capabilities. Remember, infrastructure as a service, everything you need to do to replace your own data center. And then we have PaaS or platform as a service. This is where the CSP provides both hardware and development platform that includes software development tools such as runtime environments. This lets the client focus on software development while the CSP manages the hardware and development environment. Know what the three cloud deployment models are? These are pretty easy, but still something you need to remember: public, private, and hybrid. So you might also see in literature that refers to multi-cloud environments. Multi-cloud refers to having multiple clouds doing the same or specialized task and not the deployment model. So what this means is, public, you're purchasing it from somebody else. Private, you own it all. Hybrid is a combination of both. Multi-cloud means that you're using the cloud service providers for whatever they do well that suits your purposes. These are the way a lot of my customers do things. They run things in Google when they want to use Google products. They run Microsoft when they want to do business type solutions. And they use Amazon when they want to take advantage of the services that Amazon has to offer. Be able to list pros and cons for each of the three deployment models. So, a public cloud means that the client does not need to invest in hardware that'll go obsolete in a few years, but downsides can be lack of control and security. Private cloud allows a company to retain security and resource control, but usually costs more because of the hardware replacement lifecycle. Hybrid clouds are the best and worst of both worlds because they combine features of public and private clouds. Again, you put those into your own words. Um, there's there's pros and cons, and you can have a conversation. And I will give you a good example. Today, I was on a call with a customer. They started out saying how going to the cloud was more costly than they had anticipated, and that they didn't see how it could ever um, be worth it. So I started in and I started telling them about what you have to do in order to cut cost. And I can tell that this customer flat out did not want to hear it. So I didn't pound it on him, but I left him with a few things to think about and explained to him, if you run your data center exactly the way you run it today in the cloud, you're going to spend more money. But if you shut down, start up, shut down, or if you take advantage of savings plans, or you take advantage of reserved instances, there are ways to save money. And so, again, I left him with some things to think about. I may or may not have won him over, but I didn't want to, that wasn't a situation where I wanted to browbeat him. Now, if one of my resources came up to me, somebody who works for me, and said the same thing, I wouldn't have backed down. I would have said, we need to talk about this, and I need to make sure you understand how this really works. So, again, all of these things, different situations, you just want to load yourself up with what these things mean. So, again, right there where it says retain the private clouds allow the company to retain security resource control, but usually cost more because of hardware replacement life cycle. You can talk about that and go into that. And then you can also have some conversations around, is it better for you to have your own security, or is it better to have somebody like Amazon run your security? So just a little bit more details on that. Know the 6 characteristics of clouds. Clouds are elastic and provide self-service, offer scalability, have broad network access, may offer pay-as-you-go, and have high availability. And then the next one here, be able to explain what it means for a cloud to be elastic. Elasticity within a cloud means that the cloud's resources can grow or shrink as the client's needs change. Clouds can do this because they utilize resource pooling. Sometimes you will hear this called rapid elasticity. Be able to describe what self-service means. In a cloud environment, much is automated. This includes allowing clients to request or access additional features without requiring intervention from the service provider. So there, self-service means you don't have to go to somebody else. You sign into the console and you have the power to do everything that you need to do. Be able to explain what scalability in the cloud is. Scalability is closely linked with elasticity. This just means clients have the ability to use more or fewer resources as needed. Be able to describe what broad network access means. Cloud clients can access resources regardless of the hardware or operating system they run. This can mean access for desktops, laptops, and mobile devices running on Windows, Mac OS, or mobile OS like iOS or Android. Be able to explain what pay-as-you-go means. So cloud providers track client usage and charge them for services used, much as public utilities do. In some payment models, clients only pay for the services they use, which is called pay-as-you-go. Be able to describe what availability means in the cloud. It means that resources are available whenever the client needs them. Most commonly, you will hear this referred to as high availability. The goal for the CSP is to provide uninterrupted services. Understand the shared responsibility works. So the shared responsibility model works. Shared responsibility model pertains to the cloud security. A CSP is responsible for security of the cloud. The client is responsible for security of what's in the cloud. Now, that shared responsibility model extends a little bit more than security. Your book really focuses on that security, but just know that it actually goes a little bit higher and it's a little broader than just security. But for now, we'll focus on where the book wants us to focus. Understand what disaster recovery is. Disaster recovery is the ability to become operational after a disaster happens. Disasters can include natural disasters, cyber attacks, hardware or software failures, or human error. Know how redundancy works in a cloud environment? Cloud providers can provide redundant systems, which is like fault tolerance. This means if one component of the system fails, there's no loss of functionality because the redundant system takes over. Redundancy can apply to hardware, software, network infrastructure, geography, processes, or data. Again, the goal is for your customer to never know there was an issue. Know what an RPO is? Recovery Point Objective specifies how old data can be to still be considered current or useful to restore normal operations. RTO is the Recovery Time Objective, and it defines how long the system or services can be down before being restored in the event of a disaster or outage.